In a freezing world, the Earth stood at the edge of its endurance. 20,000 years ago, ice ruled the planet. Vast sheets of frozen stone smothered entire continents, stretching from the Arctic deep into the heart of North America and Europe. Sea levels fell, coastlines vanished, and land bridges emerged where oceans once flowed. Winds scoured the exposed plains, carrying dust across barren landscapes locked in cold and silence. This was the last glacial maximum, the peak of the most recent ice age. "55 million years ago, the Earth was a very different world. This was the greenhouse Earth, a planet wrapped in heat, where the atmosphere held far more carbon dioxide than today, and the oceans stored warmth from pole to pole. There were no permanent ice caps. Snow was rare, fleeting, and unfamiliar. The concept of a frozen world had not yet been written into Earth's story. At the poles, darkness still came with the long winters, but cold did not. Forests grew in the Arctic, thick with dawn redwoods, palms, and broadleaf trees. Rivers flowed through landscapes that today lie buried beneath ice. In the warmth, reptiles thrived far from the equator. Tortoises, crocodile-like animals, and heat-loving life flourished where ice would one day dominate. The seas were high, flooding continental margins and creating vast shallow oceans, rich with life. Coral reefs expanded, plankton bloomed, and warm currents carried tropical heat across the globe. From the depths of the oceans to the humid skies above, Earth operated as a single, connected heat engine. Rain fell often and heavily. Storms were powerful. The world was lush, green, and alive, but also restless. Beneath the warmth, immense forces were at work. Mountains rising, continents drifting, carbon slowly being locked away in rock and sediment. This was a planet at its thermal peak, balanced on the edge of change. Though the Earth appeared stable, the long cooling journey had already begun, one that would, over millions of years, transform this greenhouse world into a planet shaped by ice. This was Earth before glaciers, before snow defined the poles, before cold became a global force. "34 million years ago, the world changed. For tens of millions of years, Earth had lived in warmth. Tropical forests reached toward the poles. The oceans were high and gentle. Ice was a memory from a distant past. But now, at the edge of the Eocene, the planet began to cool, and it would never fully return. The air grew thinner, drier. Carbon dioxide in the atmosphere fell, and with it, global temperatures dropped. What had been a greenhouse Earth slowly lost its heat. Seasons sharpened, winters lengthened. Far to the south, over the vast landmass of Antarctica, snow no longer melted away each summer. Year after year, it piled higher. Ice spread outward, bright and relentless, until a continental ice sheet was born, the first in more than 200 million years. As water became locked in ice, the oceans withdrew. Sea levels fell, exposing new coastlines around the world. Cold currents began to circle Antarctica, isolating it from the warmth of the tropics. The Southern Ocean became a barrier of moving water, sealing the continent in cold and reinforcing the planet's descent into an icehouse state. Across the continents, life was forced to adapt. Dense tropical forests thinned and retreated. Open woodlands and grasslands began to appear where jungles once stood. Many ancient species vanished, unable to survive the cooling world. Others evolved, faster, tougher, better suited to open landscapes and changing climates. This was not an ice age as we know it today, but it was the turning point, the moment Earth crossed a climatic threshold. From this time forward, ice would be a permanent part of the planet. The rhythm of cold and warmth, glaciers and retreats would define Earth's future. 34 million years ago, the age of ice began. 5 million years ago, during the early Pliocene, Earth was a warmer world, calmer on the surface, yet quietly changing beneath. Global temperatures were higher than today by several degrees. Ice still clung to Antarctica, but it was smaller and less stable. Greenland, now buried beneath kilometers of ice, was largely green, its hills and valleys shaped by rivers, not glaciers. The poles were warmer, the contrast between equator and high latitudes far less extreme than in the modern world. The oceans told the deeper story. Sea levels stood tens of meters higher, flooding coastal plains and reshaping shorelines across the globe. Warm currents carried heat farther north, especially as the rising Isthmus of Panama altered ocean circulation. The Gulf Stream strengthened, feeding moisture into the atmosphere, laying the groundwork for massive ice sheets that had yet to form. On land, forests reached farther toward the poles, spreading across regions that would one day freeze. Grasslands and open savannas expanded, particularly in Africa, where grazing animals flourished and early human ancestors began adapting to a more open, seasonal landscape. The world was greener, wetter, and more biologically rich in many places than it is today. Yet this warmth was not a return to the greenhouse Earth of the distant past. It was a transition. The planet was slowly cooling, step by step, guided by shifting continents, changing currents, and falling carbon dioxide levels. 5 million years ago, Earth stood at a crossroads, still warm, still stable, but already drifting toward a colder future. Within a few million years, ice ages would begin to grip the planet, transforming this gentle world into one shaped by ice, wind, and cold. Around 2.6 million years ago, Earth crossed a climatic threshold. The planet entered a new chapter in its history, the beginning of the Ice Age, known to scientists as the Quaternary glaciation. For millions of years before this moment, Earth had been slowly cooling. Mountain ranges such as the Himalayas and Rockies had risen high into the atmosphere, accelerating the weathering of rocks and quietly drawing carbon dioxide out of the air. With less greenhouse gas to trap heat, global temperatures continued their long decline. At the same time, ocean circulation was reorganizing. The closure of the Isthmus of Panama, completed shortly before this period, redirected ocean currents. Warm waters were pushed northward, increasing evaporation and snowfall at high latitudes. Summers became too cool to melt all of this snow, and year after year it began to accumulate. In the northern hemisphere, especially across Canada, Scandinavia, and Siberia, the first large continental ice sheet started to form. Glaciers advanced from the mountains, spreading outward onto the lowlands. Sea levels dropped as vast amounts of water were locked away as ice. This was not a single, sudden freeze, but the start of a rhythmic pattern. Earth's orbit and axial tilt subtly changed the distribution of sunlight through Milankovitch cycles, triggering alternating cold glacial periods and warmer interglacials. Ice advanced, retreated, and advanced again, growing larger with each cycle. By 2.6 million years ago, the world had shifted into a new climate mode. Ice ages would now dominate Earth's rhythm, reshaping landscapes, redirecting rivers, and driving the evolution of life, including the earliest members of the human lineage. The Age of Ice had begun. For millions of years, Earth's climate has followed a slow, celestial rhythm, one set not by volcanoes or oceans, but by the planet's own motion through space. These rhythms are known as Milankovitch cycles. Earth does not orbit the Sun in a perfectly stable way. Its path gently changes shape, its axis slowly tilts. And over time, that axis begins to wobble like a spinning top. Each of these movements unfolds over tens of thousands of years, subtly altering how sunlight reaches the planet. First, there is the shape of Earth's orbit. Sometimes it is nearly circular. At other times, it stretches into a gentle ellipse. This change, called eccentricity, slightly alters the amount of solar energy Earth receives and amplifies seasonal contrast. Then there is Earth's tilt. The angle of the planet's axis slowly shifts back and forth. When the tilt is greater, seasons become more extreme, hotter summers and colder winters. When the tilt is smaller, summers grow cooler, especially in the far north. Finally, there is the wobble. Earth's axis slowly traces a circle through space, changing the timing of the seasons. This process, called precession, determines whether summers occur when Earth is closer to the sun or farther away. On their own, these changes seem minor. But together, they control one crucial factor: the strength of summer sunlight in the northern hemisphere. Ice ages are not born from brutal winters. They begin with weak summers. When summers are too cool to melt all the winter snow, ice begins to accumulate. Year after year, layer upon layer builds up. Snow turns to ice. Ice spreads across the continents. As vast ice sheets grow, they reflect more sunlight back into space, cooling the planet even further. Carbon dioxide levels fall. Oceans and winds reorganize. The cold deepens. This is how Earth enters a glacial age. Eventually, the cycles shift again. Summers grow warmer, ice melts, sea levels rise. The planet returns to a brief, warmer pause known as an interglacial. For the past 2.6 million years, this slow dance between ice and warmth has defined Earth's climate. Milankovitch cycles do not force the ice ages, but they set the tempo, guiding when glaciers advance and when the world thaws once more. It is a story written not in centuries, but in deep time, etched into the ice itself. At the dawn of the Quaternary, nearly 3 million years ago, Earth begins a quiet but profound transformation. The planet is cooling, not abruptly, but steadily. The warmth of earlier ages fades as the first great ice sheets take hold in the northern hemisphere. Glaciers appear across high latitudes and mountain ranges, advancing and retreating like slow, cautious waves. This is the early Quaternary, a world learning to live with ice. Climate rhythms are gentler than those to come. Glacial cycles follow a regular beat of about 40,000 years, guided by subtle changes in Earth's axial tilt. Ice grows, but it does not yet dominate the continents. The cold phases are shorter, the warmth between them more frequent. The planet breathes in a steady, measured rhythm. Sea levels rise and fall, but only modestly. Coastlines shift, exposing plains and then reclaiming them. Forests contract during colder intervals and return when warmth resumes. Grasslands spread across Africa and Eurasia, creating open landscapes where new forms of life begin to thrive. The world is drier than before, yet not extreme. Winds carry dust across continents, but ecosystems adapt and endure. Large mammals expand across the land, evolving traits suited for cooler, more seasonal climates. Among them, early humans take their first steps into a changing world, shaped by shifting environments and growing unpredictability. Though the ice is still young, its influence is unmistakable. The early Quaternary sets the stage for what lies ahead, a future of deeper cold, longer glacials, and sharper climate swings. It is a transitional age, where Earth leaves behind its warmer past and commits slowly and deliberately to an era defined by ice. As the Quaternary advances into its later chapters, the rhythm of Earth's climate changes, and the cold tightens its grip. By about 1 million years ago, the planet has crossed a threshold. Glacial cycles grow longer and more powerful, stretching close to 100,000 years. Ice no longer comes and goes gently. It surges. Vast continental ice sheets expand again and again, each advance larger than the last. The late Quaternary has begun. Temperatures fall further than before. Summers grow too cool to melt all the winter snow, and year by year, ice accumulates. In the northern hemisphere, glaciers spread outward from Canada and Scandinavia, grinding landscapes beneath their immense weight. Mountains are carved, valleys deepened, and entire regions are transformed into frozen deserts. The world grows drier and harsher. Sea levels drop dramatically as water is locked away in ice, more than 100 meters below modern shores. Coastlines retreat, exposing broad continental shelves and land bridges that connect continents. Winds strengthen, sweeping dust across open plains, while forests shrink and grasslands and tundra expand. Life adapts or retreats. Mammoths, woolly rhinoceroses, and reindeer roam the cold steppes. Humans follow the margins of ice and grassland, learning to survive in a world of long winters and short summers, guided by fire, tools, and cooperation. Then, around 26,000 years ago, the cold reaches its peak. The last glacial maximum is the climax of the late Quaternary. In a frozen world, North America lay beneath an empire of ice. From the high Arctic to the heart of the continent, the Laurentide ice sheet dominated the landscape. It was a vast, living mass of frozen water, kilometers thick in places, spreading outward from central Canada. Its southern edge pressed deep into the present-day United States, burying New England, the Great Lakes, and the northern plains beneath a silent white expanse. The land groaned under its weight. Rivers were rerouted or erased, and the surface of the earth itself was pushed downward by the sheer burden of ice. To the west, another giant held the mountains in its grip. The Cordilleran ice sheet draped itself across Alaska, British Columbia, and the coastal ranges of the Pacific Northwest. Glaciers spilled through valleys and fjords, carving sharp peaks and deep inlets as they flowed toward the sea. In some places, this ice met the Laurentide, sealing off the interior of the continent and reshaping atmospheric and oceanic circulation. Farther north, the Inuitchan ice sheet covered the high Arctic islands, merging with Greenland's ice and reinforcing the polar stronghold. Together, these ice sheets reflected sunlight back into space, intensifying the cold and locking the planet into its glacial state. At the height of the last glacial maximum, the oceans of the world were locked away in ice. Vast ice sheets covered much of the northern hemisphere, and with so much water frozen on land, global sea levels fell dramatically, by about 120 meters compared to today. Coastlines shifted outward, and the familiar shape of the continents changed before the eyes of time. Shallow continental shelves emerged from the sea, forming wide coastal plains where waves once rolled. In the north, the ocean retreated to reveal the Bering Land Bridge, a broad, wind-swept corridor of tundra that connected Asia and North America. It was not a narrow crossing, but a vast landscape, home to cold-adapted animals and the pathway for human migration into the Americas. Along the Atlantic and Gulf coasts, the shoreline lay far beyond its modern position. Rivers carved deep valleys across the exposed land, flowing for hundreds of kilometers before reaching the distant sea. Coral reefs, deprived of light and warmth, stood stranded or dormant, while new shorelines formed at the edge of the lowered ocean. The oceans themselves were colder, denser, and more stratified. Currents shifted, reshaping global heat transport and reinforcing the icy grip of the glacial world. Storm patterns changed, and the rhythm of tides and waves followed coastlines now long submerged beneath modern seas. Global temperatures were several degrees colder than today, and in many regions the chill was far more severe. The air was dry and heavy, stripped of moisture by the cold, and snowfall fed the glaciers that advanced slowly but relentlessly across the land. Vast areas of North America and northern Eurasia lay buried beneath ice, while beyond the glacier margins the landscape was stark and windswept. Here, tundra and steppe ecosystems dominated. Open plains of grasses, sedges, and hardy shrubs, adapted to short summers and bitter winters. Trees were rare, their growth limited by frozen soils and low atmospheric carbon dioxide levels. In lower latitudes, the cold reshaped ecosystems in subtler but profound ways. Deserts expanded as rainfall weakened, and many forests retreated or fragmented into isolated refugees. Tropical rainforests thinned, replaced in places by dry woodlands and savannas, as cooler oceans reduced evaporation and weakened monsoon systems. The oceans, too, bore the mark of the Ice Age. Sea levels dropped as water was stored on land, and surface waters grew colder, especially in the North Atlantic. Powerful currents shifted, altering the distribution of heat and nutrients. Marine ecosystems changed as productivity increased in some regions, fueled by dust-blown minerals, while coral reefs struggled in the cooler, lower seas. Across the exposed plains of the continents, megafauna thrived in this harsh world. Mammoths, bison, horses, and giant ground sloths grazed the cold grasslands, pursued by formidable predators. Humans, newly arrived in many regions, adapted to the extremes, following migrating herds, mastering fire and stone, and surviving at the very edge of the ice. Across vast open plains of tundra and steppe, grasses and hardy plants clung to the soil, feeding some of the largest animals ever to walk the earth. Woolly mammoths moved in slow, deliberate herds, their thick fur and curved tusks shaped by cold and wind. Bison, horses, reindeer, and musk oxen roamed the grasslands, while predators, saber-toothed cats, wolves, and cave lions followed in their wake. In these harsh landscapes, plants lived fast and low to the ground. Summers were brief but intense. For a few precious months, flowers bloomed, insects emerged, and the plains erupted with life before winter returned once more. Farther south, forests survived only in scattered refugees. Trees clustered in protected valleys and along coasts, sheltering smaller animals, deer, birds, and countless mammals that adapted by migrating, hibernating, or shrinking their ranges. Life was constantly on the move, tracking warmth, water, and food across a changing land. Humans, too, were part of this world. Small bands of hunter-gatherers lived close to the rhythms of ice and season. They followed migrating herds, built shelters from bone, wood, and hide, and used fire as both warmth and protection. Stone tools were refined, clothing became essential, and knowledge, passed through generations, meant survival. Across exposed lands like the Bering Plain, people crossed into new continents, unaware they were reshaping human history. Along the coasts where the sea had retreated, humans and animals alike exploited rich marine and shoreline resources. Shellfish, fish, and seabirds offered vital food in an unforgiving climate. Slowly, almost imperceptibly, the frozen world began to change. As Earth's orbit shifted and sunlight strengthened in the northern hemisphere, the great ice sheets reached their limit. The cold loosened its grip. Glaciers thinned, cracked, and started to retreat, releasing vast rivers of meltwater across the land. Sea levels began to rise, flooding exposed plains and drowning ancient coastlines. Forests crept northward into lands once ruled by tundra, and new ecosystems took root in the warming climate. The age of mammoths and endless ice was fading. The last glacial maximum did not end in a sudden collapse, but in a long, powerful thaw, one that reshaped the planet and set the stage for the world we know today.